Okay, so here you can see there is several steps that you need to know under your synchronized counter design. First step, describe the general sequential circuit. So you need to know the condition, what is the input and also what is the output. Second, you need to develop the state diagram. This one you already done. Similar also in your step 3. This part you already done, but now you need to add another one, is your next stat table. So if last time you have what is the condition, might be you have J, K, and then you have Q. So this is the Q output. You're going to have like 0, 0. I just give example, okay? So here after that, you're going to have another condition of Q plus maybe. We're going to look into the symbol after this. I just give you the example and maybe we just assume this as a previous Q. You have previous Q, but now this is your previous stat table. Now for your synchronized counter design, you need to have another one, which is your one. I prepare ni. Next stat table. So after this output, you're going to get this. After this output, you're going to get this. So this is the next stat table. How you're going to derive it, how you're going to create. Okay. So step 4. So you need to remember all the steps, okay? Similar to what last time we did. We have the block logic diagram, how the connection look like, and then we have the timing diagram. Third one, we have the stat table. And lastly, we come out with our stat diagram. But now it's like vice versa, you can see here. And step 4, you create the flip-flop transition table. What is the meaning by transition table? This is a new term for you. Step 5, use K-map to derive the logic equation. Okay, before about K-map, this is very funny. What is happened yesterday? The person in charge, the lecturer that marked your question, find out there is our test 2 question in one platform. I think maybe more. We just found out at one platform just now. There is student published there. I hope that it is not coming from my section. Okay, I hope it is not coming from my section because we noticed that we have section 1, section 2, section 3, 4, 5, 6. Okay, let's say this is my section, this is my section, this is my section. And the lecturer mentioned there is a sequence copy, paste, and discussion. There is one student, maybe this person published into one website about your task 2 question, and then he discussed or maybe he give a question to section 2. Maybe inside also there is several other students that copy paste, and it continues cross section. I already mentioned, okay, since your day 1, your digital logic, don't do similar mistake with your senior. Last time your senior need to repeat again. Your senior need to repeat digital logic. Are you going to do these similar things? if you think you cannot answer, don't ask your friend, because this person do a wrong thing in CAMAP, and everyone believe with him. I guess him or her, I don't know yet. We still try to find out. So if you feel guilty, if you think that you are doing it wrong, you discuss with your friend, please inform us before we find out, because this person doing totally wrong through the CAMAP, but everyone following similar things. So you not just, I don't want to uh, call it what. So you know what it is, because you believe in others. I already mentioned last time, don't depend on others, don't believe in others. Then now it's happened. So later on, you're going to find out who did it and who going to repeat this subject. Things is already like, now it's week what? Week 10 ah? I forgot already. You want to repeat since week 1? What are you going to do? You just waste your several months by just doing stupid things. You just copy others, you discuss with others, you publish the question to platform just to ask a person, help me with this question. And the person you think it is expert, they give you a wrong answer. Okay? I don't know what we're going to do. Let me check what is the update. Digital logic. Because just remember about this, yesterday we discussing about the question and about the student who did the copy paste. Okay. It is for persons that copy until like several section. That is one question only, but about the questions that coming out to the platform, we're going to find out who did it, and if you did, and if you are from section 3, section 6, or section 9, I'm not going to help you with anything, even your carry mark or even things, because if you feel guilty, it's going to be, if you're guilty, you're going to totally repeat. It is not asking about your test 1 mark, although you get test 1 is 100%, you get 0. Okay, so we already find out several students, we still trying to find out more. And when we already tapi meniru, okay. You did team working very well. And then after this, if it's happened for test 2, maybe we're going to give a warning and you get 0, you need to repeat maybe. And if it's going to repeat also to final exam, you're going to repeat the whole course. But for these things, I don't know yet. Miss Marina is trying to find out what we're going to do a punishment. Just wait and see, okay? So here is the things about CAMAPs. Last time you already learned about CAMAPs, and yeah, Alia asked us related to what module that we're coming out for final exam, right? But for your final exam, although it is not specific under your module 5, under your module 4, but still you can see you need to have a knowledge using CAMAPs. Okay, so you still need to have a knowledge using the CAMAPs. And it's very funny last time about the CAMAP thing. I think we didn't learn about this. I think it is look like this, your question. Slightly similar, but there is one person doing like this. Okay, This is the boss, I guess. And then all others is the workers who just follow the boss doing the similar. We didn't learn like this. We learn it should be like this only, or maybe like this, isn't it, to group. But there is no cross like this. So everyone get wrong, and we're going to uh what try to find out who's the one who copy each other, who's the one that published the question. So just wait for your punishment. I hope this will be a lesson for all of you. Although I already repeat several times, this is a lesson for you to learn from your friend mistake. Don't repeat similar things. If you think you cannot answer, okay, just try your best. Maybe you can get like 2 marks or even 1 marks. It's okay, rather than you need to repeat the whole digital logic subject. Okay. Now, step 5. Use CAMAP to derive the logic equation. So you think that you still remember? And step 6, implement the counter implementation. So let's take a look how the synchronized counter design look like. Okay, this is new things I mentioned just now. Step number 4, create a flip-flop transition table. How it is look like? So you need to, siapa yang WhatsApp I banyak kali ni? Okay, you need to see here. This is your normal JK flip-flop. You're going to have a condition of 0, 0, 0, 1, 1, 0, 1, 1. Why you have two situation for 0, 0? Why you have situation for 0, 1? You got 2. Because last time, if you say remember, you need to have the previous Q with the 0 or 1. Previous Q 0 or 1, previous Q 0 or 1. Because last time we did try to justify on the summarization table. Okay, after we have the things, we're going to finalize that 0, 0, what is our output? Pasal 0, 1, what is our output? 1, 0, what is our output? And 1, 1. So let's take a look. This is your present state. This is your next state. This is the one that I mentioned. Next state table. Okay, before this, if you still remember in your module 7, for your JK, for your flip-flop, for your, what else? For your lectures, we try to look previous Q. If previous Q is 0, what will happen for your present, which is our current output for our Q? If it previous is 1, what is the output? And you already know that if it's 0, 0, 0, 0, it's going to follow your previous output, which is no change. And for your Q 0, 1, 0, 1, 0, 1, if your previous Q is 0 with the condition of 0, 1, you're going to get 0. If you have your Q is 0, 1 and your previous Q is 1, you're going to have 0 also. So that's why you summarize it to be 0 or reset. Similar also with your 1, 0, you're going to get 1. And lastly, for your JK, it's going to be toggle. 1, 0. It's going to toggle from your previous. Okay, this is the summarization And this is the thing that you need to remember. Now, you need to have your present state here, and your next state is your n plus 1, next. Okay, this is the symbol for next state. If your present state is 0, what will happen to your next state? This is not previous Q, okay? This is the present one. If it is a 0 and 1, what will happen? It's totally similar because they will be your previous now and it's going to be your current now. So you're going to refer to your JK through table in your module page 228. This one is the things that you remember. So you're going to follow everything. No change, 0, 0, 1, 1, and then toggle. Similar just now I give you, which is our previous, and also the current one is the present, right? But now the present will be your previous, and then your previous will be your present now, and then your current will be your next table. So referring to your table of your JK. So this will be your creations of your next stat table. Okay, then you can see here, we look into the previous state of 0. If it is 0, 0 and 0, 1, it's going to be 0 also. But if it is 1, 0, 1, 1, previous is 0, we're going to be 1. So if our J is 0, K is 0, or a 1, you can see here, it's going to be X. Later, we're going to look into what is X. What is also the X here for the blue color and also green color. J is 0, K is 0. You can see J is also still a 0 and K is now changed to 1. If your previous one is 0, your output for your next Q will be 0 also. And if your J is 1 and K is 0 or 1, or present is 0, your output will be 1. Your output will be 1. Okay, let's take a look. So this will be your flip-flop state here. You can see it's going to be Y, it is X here. Because it doesn't matter if it is 0 or 1. We call as X. If you still remember, which is the don't care. The don't care here is fixed, 0 and 0. You can see here, 0, 0. And the green color, okay, the green color. And our K is 0 or 1. We call as X. And another situation, the blue color here, J is 1, fixed. And our K, it can be 1, it can be also 0. And because of this, we call it as X. With this following condition, you can see, if we look into this first, okay? Because just now we look into at the present state as 0, present state as 0 first, okay? Now we have, if the J is 0 and the K whether it is 0 or 1. If your Q present state at this state is 0, your next state will be also 0. You can see here. This is a new summarized table. Later on, you need to remember. Okay, next, the blue situation here. J is 1. K, whether it is 0 or 1, 0 or 1, 0 or 1, it doesn't matter. You're going to have previous as 0. Your next step will be 1. Okay, you can see here. Okay, that is the first thing about your present will be 0. Next, we're going to see here the situation of present state is 1. Present state is 1. Present state is 1. Present state is 1. What will happen? What you're going to do is maybe you're going to change at the condition of J and K. Now we have this is going to go 1. This will be going to go 1. What is the condition? J is 0. K is 0. And here, J is 1. K is remain 1. So it's going to be X. So I look at this and this. Okay. What is the condition? I have first condition as J is 0, K is 0. Another condition is J is 1, K is remain 0. So I'm going to get the similar things just now, the green color, the blue color here. So I get this one first. Okay, next, I'm going to look into another situation, which is at this side, my present is 1, my present is 1, but the next state is 0. What is the conditions? It's going to be J, Q will be from just now, 1 to be 1. And then for this one, 1 to be 0. Okay, for here, I have J equal to 0 or 1, or we can call it as X, and the K here remain 1. So what is the truth table that I can do? Okay, maybe just now I have here Qn plus 1. Okay, I have the conditions of 1, and then my Qn will be, okay, I pick this one first, 0. And another one is previous is 1, and then here will be 1. What is the condition of my J and K? My J over here will be X, and my K is 1. For this one, my J is X, my K is 0. From this stat table, from this present tables, next stats tables, you're going to have come out with another summarizations for this. So you can see just now we did this together. Okay, so I repeat again how you're going to come out with this another summarized table that you need to remember, which is your next stat table. First of all, this is your normal JK flip-flop. Okay, this is your normal JK flip-flop. You still remember if 0, 0, no change. If 0, 1 is going to be reset. If 1, 0 is going to set, and another one is will be toggle. And when you have the present state of 0, 1, 0, 1, 0, 1, 0, 1, what is the next output? It is depend on this, isn't it? Last time. Okay, so you're done with this understanding because this one is very easy to understand. You just look into your previous output, going to have no change. For this part, no need for you to look into for your previous because it's going to be reset. And this also similar is going to be set. And lastly, it is going toggle, so you're going to look into your previous one. It's going to be toggle to your previous. Okay, by referring to this table, you can come out with the summarization, another summarization for your flip-flop state and also your present next state table. How are you going to define? You're going to see in terms of previous one is 0. So there is a condition of your previous one is 0. You're going to look into, after that, next step will be 0. This is your next step will be 0. This is your next step will be 0. So in these two conditions, you look what is the input of your JK. First, your J is 0. So that's why you remain 0 because both condition is 2, 0. And another one is going to look into K. K is 0 and K is also 1. We have these two conditions. Both conditions going to come out with from 0 to 0 also. Then you're going to do X. You're done with this part. Now you're going to move to another one from 0 to 1. From 0 to 1. If your previous is 0, your next state will be 1. When? What will happen? When you're going to have this, you need to have the JK input of these two. So let's take a look. Now your J is fixed as 1. So you just let 1 here. And then you check your K. K first is 0 and another one is 1. You're going to have 0 and 1. So these two are going to trigger your present state and next state to be from 0 to 1. So it's going to be X. Because it doesn't matter whether it is 0 or 1 for your K, your next output of your state will be 1 with this condition. So you're done with this part. Now you look into the next is when you have the present state of 1. You have present state of 1, have a present state of 1, you have present state of 1, and present state of 1. You're going to have the next state of 0. So where is it? This one and this one. So check your condition of your input. Your J is 0. Your J is 1. So because both, you're going to have X. How about your K? K is 1 and K is 1. So it will be 1 here. So done at this part. Another one is when you have present state is 1, you're going to move to 1 also, remain, no change. When will be the condition? You're going to have 0, 0 and another one, 1, 0. Your J is 1 and 0. It's going to be X. And your K is remain 0 here. So this is the true, this is the tables that you need to remember. Next, by getting this next step table here, this is your next step table here. By getting this table, you're going to draw your state diagram. Your state diagram you're going to have your present state of 0. And then your next state is 0, 0, 0. Wait, 0 and 1, yes. You have your present state is 0, and your next state is 1. Okay, I have these two, 0 and 1. I'm going to go for, if let's say my present state is 0, I'm going to go to the next state is also 0 when I have the condition of 0x. And then from my 0 here, I'm going to go to 1 with the condition of 1x. When I have 1, I'm going to go to the 0 here with the condition of x1. And another one is I have this 1 to the 1 also. It's going to be x0. So this is how I'm going to come out with the things here. Okay, in this diagram, it shows you basically all the condition for this one. Okay, we go through one by one. When we have the previous as 0, we're going to go to the 0 back with these two conditions. 0, 0. You can see here 0, 0, and also 0, 1. So you're going to summarize to be 0x. Next, you're going to have from 0 to 1. From 0 to 1. What is the condition? From 0 to 1. The condition will be 1, 0 and 1, 1. 1 will be remain 1, 0, 1 will be x. We have next situation. Let me pick this 1 and 1. 1 to go to the 1 back with the condition of 0, 0, and another one is 1, 0. So here 0 and 1 will be x, 0 will be 0. Second, after that, the final state will be 0, 1, 1, 0, 1 to go to the 0. What is the condition? The condition is 0, 1, and another one is 1, 1. So 0 and 1 will be x, 1, 1 will be 1. So this is your JK flip-flop state diagram. Okay, any question?
No, doctor.
Okay, let's remove. Okay, this one is later you can try to do construct the similar things for your D flip-flop and T flip-flop. Let's do it later. Later after this, we're going to go for our Jamboard. Before that, let's do the summarization, how you're going to get this. Okay, this is a table just now you already create. And what happened if you're going to do for your D flip-flop and another one T flip-flop? You're going to get the output of Q 0. Okay, you're going to look into the conditions of if let's say Qn is 0, and your next step will be n plus 1 will be 0. If let's say it's going to be 1, 0 to 1, what will happen? 1 to 0, what will happen? 0 to 1, what will happen? 1 to 1, what will happen? So you need to check all the condition also. Then you're going to get the summarizations of this table. Okay, just now we have, let's say for our Q, I'm going to, because there is two question. It's okay, we're going to discuss together after this. Okay, we go directly to design 2-bit synchronized counter for JK flip-flop. This is referring to your this table. Okay, going to follow step by step. Step 1, to design 2-bit synchronized counter using JK flip-flop. So there is no input or output element in this design. Step number 2, draw the state diagram. Because 2-bit synchronized counter, you're going to have 0, 0, and then you go to 0, 1, to 1, 0, and then 1, 1. Back to the 0, 0. After that, you need to create the next step table. For this part, if you have this condition of your Qn 0, 0, what will happen for your Qn plus 1? You're going to go to the 1. And then you have, what else? 0, 1. And then you go to 1, 0. 1, 0. And then you go to the 1. So 1, 1, you're going to go to 0, 0. So you need to have all this situation, create the step table summarization. You have 2 digits over here. 0, 0. This is your condition of 0, 0. You're going to go to 0, 1. You have the condition of 0, 1 here. You're going to go to 1, 0. And after that, you have the 1, 0 here. You're going to go to the 1, 1. And another one is 1, 1. You're going to go to 0, 0. So this is the next step table that you need to create. Next, you need to construct the flip-flop transition table. How are you going to get? This is the flip-flop transition table. You need to check what is the conditions throughout of the JK condition. You know already, if you have 2-bit, you're going to have 2 JK flip-flop. If you still remember, this is your JK0. This is your flip-flop 0. This is your flip-flop 1. It's going to be J0, K0, J1, K1, isn't it? So this is your transition table that you need to draw depending on your flip-flop. How are you going to determine your input? It's going to depend on the value of your Q. You can see here, this is your 0, 0, 0, 1. What is the JK? So you're going to see at this condition, 0 to 1, 0 to 0. This is 0, and then this is 1. So from here, you're going to get the conditions when you have 0 to 1. 0 to 1. What is the condition of 0 to 1? You're going to have 1x. And this one is 0 to 0. What will happen? 0 to 0. 0 to 0 is 0x. How are you going to determine this? Because this one you can see here, 0, 0. And this one is coming out from, okay, just now we already derived this table. This is the basic table that you need to remember after we derive. You need to understand how you're going to get this. Rather than you will be like, okay, I just want to remember, I don't care how it's basically get this table. It's okay to get and to remember that. So, but it's better for you to understand the flow. Just now, I already shows you how you can get this table. Try to do also D and T after this. Okay, so the step 1, you need to do the 2-bit synchronization. For the first time, there is no input and output element because you don't know yet, right? And you need to draw the stat table for 2-bit synchronized counter. You know, basically it's going to give you like counting out, counting down. So this one is counting out. After that, you come out with your third step, next step table. Just now, we already have this one for the conditions of 1 bit only. Just now, we have the condition of 1 bit. But for this next step table, we know already from our stat diagram, we can derive this. This is our Q0. This is our Q1. Sorry. Yes, this is our Q0, this is our Q1, but with the following of n, this is n plus 1. So this one you can see here, our Q0. Our Q0 for the next one will be 1. Our Q1 here, this is our Q1 for the next will be 0 to 0. 0 to 0. Similar also after this is goes to here, this one goes to here, and this will be goes to, here, and this one will be here. Depending on your MSP, LSP also. So you're going to come up with this next step table. After that, you have the thing here is your flip-flop transition table. Flip-flop transition table, I already mentioned to you, you just need to see 0 and 0, but from previous state to the next state, what will happen? 0 to the 1. So you see 0 to the 1 is going to be 1x. So you look into at the 0, it's going to be 1x. And for the 1 here, 0 to the 0. 0 to the 0, what happened? It's going to be 0x. Next, we have Q, 0 to our 1. 0 to 1. 1 to 0 is going to be x. 1. And then we have here 0 to 1 will be 1x. 0 to 1. 1x. 1 to 1 x0. 1 to 0 x1. And 1 to 0 x1. Is correct or not? 1 to 0, 1 to 0. Okay. So let's take a look. The answer is correct, what I fill in, by referring to my table. So next you have the step number 5 here. I inform you you're going to use your care map. So how are you going to do your care map? So you will come up with your JK0, K0, and then after that you have another one is K1 and then JK1. Because this is your things for your K and J that you need to see the output and input. Okay, you have over here the conditions of 0, 1, 0, 1. And then you have the QM1, right? This one is J0, referring to this one. J0, you're going to have 1x, 1x, referring to your Q0, 0, 1, 0, 1. And then you have another one is Q1. But for this, it's going to refer to your present state only. And I bring this table to next. Okay, we have here. Referring to this table, we're going to look this JK first. Okay. For J0, we have 0, 0, 0, 1, 1, 0, 1, 1. This is our J0 output. And we have the Q1 here, and then we have Q0. It depends whether you want to have Q1 or like this also can. And you have the condition of Q1 as a 0 and Q1 as a 1. And Q will be 0, will be 1. And what is happened? Referring to this. If you have 0, 0, you have 0 and 0, you're going to get 1. If you have 0, 1, 0, and then you have 1, you have X. For this part, 1, 0 will be 1 and X will be X here. So using your care maps, you're going to group. X, if you still remember, it's look like a don't care situation. If you have don't care, what will happen? You're going to have either 0 or 1. So you're going to consider it if you can draw like this. If let's say you have 0 here, you cannot group 4, then you need to group like this only. Okay, next we have K0 referring to this output and refer to the input 0, 0, 0, 1, 1, 0, 1, 1 for the present state only. Then you're going to have like this. So you're going to see that if you have this condition for your care map, if you still remember, then you're going to have J equal to 1. If you have this condition also, it's going to be K equal to 1. So your connection later on, you're going to have your J0, K0, you're going to connect to 1 or high. Second, you're going to have the J1, K1, but still remember you're going to refer only for the present state 0, 0, 0, 1, 1, 0, 1, 1. And at this condition, okay, F0. Going to have Q0, Q0 bar, and you're going to have your another FF1, J1, K1. You don't know what is the input. I state here, there is no input or output element yet for the design. You don't know yet, okay? So you're going to see what is the input for J and K here. So after you drew the K-map things, you're going to get like this, which is, you can see your J1 will be similar to your Q0. Why Q0? You're going to see it is only at the Q0 as 1. And similar for your K1 here. If you have like this, it's going to similar for your Q1. If you have like this, you're going to have Q0 bar. If you have like this, you're going to have Q1 bar. Okay, so this one, you're going to see that everything is 1 for your Q0. So your input is Q0 now. How about your K1? Your K1 is also similar. So this is your input. Because it's ugly, so you can see it's clearly here. So this is the connection. This is the connection for your Q0 there. Then you're going to get your counter. This is synchronized. If you still remember synchronized, your clock will be similar. Okay, any question? For this part, any question?
No, doctor.
Okay. If there is no question, you can basically draw the table. That's a quick one. I open my Jamboard. Go back to the, okay. Have a lot of time. Now try to communicate with your groups. We're going to do our Jamboard exercise about doing the excitations of tables for D flip-flop and T flip-flop. How you're going to get the summarization just now. I already shows you. Wait, I construct the question first. Okay. Go to the Jamboard. Group odd the flip-flop. Group even the flip-flop. Okay, do the similar things like last time. pick your workspace. I guess it's only one page is enough. And then you need to construct okay, you need to construct how to get these D flip-flop summarizations, excitation tables, and another one is your T flip-flop excitation tables. So you need to come out with the table just now like this. The things that I shows you from beginning, if you have the JK00, what happened. Similar also, but now you have only one input. It is slightly smaller. You're going to have 4 tables only with the condition of present and next state, and you come out with the table like this. So now you're going to have for D and T, mana I punya pen? Okay, going to have one side only, 0, 1, whether the condition of present state will be 0, going to be 0, and then your present state is 0, it's going to be 1, let's say. And you have another condition of present state as 1, going to have 1 and then 1 to 0. So depend on what happened, you need to have all this 0, 1 only. So you have 4 tables. Just now for JK, we have 8 tables because we have 2 input. But for D, we have 0 and 1 only. We just have the present state 0, 1, 0, 1. So try to come up with this and get your next state. What is your next state? What is your next state? And you summarize. And normally you're going to get like this. Similar to your T flip-flop also. So you need to refer back your module 7. Your module 7, your D summarization flip-flop tables, and also your T summarizations. Okay, start now. 15 minutes only because it's didn't took longer, I guess, because it's have 4 table only. Okay, group 5 is already done. Because it's supposedly it's very simple. How come you get 0101 there? Where is your X? Group number 5. If you from 0 to 0. Oh, and then you have 0. And then if you go from 0 to 1, you're going to have 1. Okay, understood? And then from 1 to 1, have 1. Then 1 to 0, have 1. Hmm? Okay, let's take a look into your friend answer. Okay, done. Okay, so you can see here in group number 1, we have D flip-flop. If you still remember about your D flip-flop table, here you have 0 and 0. If your D is 0, kenapa macam ni? Okay, this one. If your D is 0, and at that time your oops. At that time, your present state is 0. Your next state will be 0. If you remember your D flip-flop table, it's going to follow the D, isn't it? If let's say D is 0, your output will be also 0. If your D is 1, your output will be 1. Okay, this is your D flip-flop. If you have 1, your present is 1. Your next state will be 0. Is it correct or not? If your D is 0, okay, follow the D. If your present is 1, it's going to be 0. Okay. Then if you have 1 here, your present is 0, it's going to be 1 also. If you have 1, it's going to be 1 also for the next state. So what happened? You're going to summarize it. You're going to have, if your D is 0, whether your previous one is 0 or whether it is 1, you're going to have 0 also for your next state table. And if let's say you have the D as 1, your next state will be 1. It doesn't matter what your Q and your present state inputs or value. So you're going to get this summarization. And this is the flip-flop state table. Mostly all of you know how to draw it. Next is the T flip-flop here. It is going to be toggle. If your T is 0, your Q will be 1. If your T is 1, your Q will be 0. So let's see if your, where is your T? Okay, this is T present state. Okay, if your T is 0 here, kenapa dia tak toggle? Is it only 1? I also forgot about your T flip-flop. But I think it's toggle. Let me check how you get this. If it's 1 here, your present is 0. Why it didn't toggle? T 0 0. Anyone have the tables? Let me check the table T1. Okay, this is my T flip-flop. Okay, toggle only at 1. 0, it will be whole or also follow your input of 0. Going to toggle at 1 only. So this is a summarized tables that you need to remember. Group number 2, right? Okay. So if you have 0 here, it doesn't matter what is your present state. Whether for this part is going to be follow exactly what your previous output is going to hold or no change if you still remember. So it's going to follow your present state. That's why you get 0 and 1 here for your Q. And for your 1, it's going to be toggle, referring for your present state. So it will be 0 to 1, 1 to 0. And then you can summarize, if your T is 0, doesn't matter if it is 0 or 1, it's going to be following your present state. This is your QN, following your present state. Similar also equal as no change is also whole. And for this part, you can see it's going to be toggle. If you still remember for your T flip-flop, that's why it's going to be toggle or a Q and bar. So this is happen. 0 to 0 is going to be 0. Yes, correct. 0 to 1 is going to be 1. 1 to 0 is going to be 1 to 0 is going to 1 to 0. 1 to 1. Okay, 1 to 1 is going to be 0 and 1 to 0 is going to be 1. So correct here. So I hope that all of you understand. For this also similar, you're going to get this one. And this is also correct, but where is your summarization table for D? And T01 toggle. And lastly, group number 7. D also, kenapa macam banyak D? Okay, TD, okay. Now finish. So I hope that you already understand the basic things. Let we move to our another example so that we can forward to next example here. Where is it? Okay. Just now we look into two-bit synchronized counter. Please remember, synchronize your clock will be similar source. So 3-bit. So you need to know, okay, you're going to have Q3, Q2, Q1, Q0, 3-bit, 1, 2, 3, 3 bits. This is Q0, this is Q1, Q3, Q2. Similar also all. Then you can see you have Q0, Q1, Q2. First thing, you need to know about the design. And second, you're going to move to your stat diagram. This is counter, okay, supposedly it's going to be count from counting up from 0 to 7 here, and then it's going to cycle. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Then repeat again. So all of these stat is going to be present to your next table. So what has happened? You need to remember about JK flip-flop. Now we have, you're going to list all the Q0. Q0, 1, 0, 1, 0, 1, 0, 1, and then everything here is stated already at your present state. Now, how about your next state? So you refer to this. From 0, 0, 0, you're going to go to 0, 0, 1. From your 0, 0, 1, going to go, your next state will be 0, 1, 0. From this, you're going to go to 0, 1, 1. From this, you're going to go 1, 0, 0. And following everything, 0, 1, 0. Saya salah. So this is, just fill in everything in your next step table. After that, you're going to do the step number 4, transition table. This is the thing that you need to refer to your JK table. And you look one by one condition. If it is Q0, you're going to look into the Q0. From 0 to 1, what is happened? So you look at the J0, K0. I also remember, I also forgot already what is JK. If you have QN plus 1, 0, 0, 0, 1, 1, 0, 1, 1. What will happen to your JK? I think this one is XX. Here is 0, 0. XX 0, 1. This one I forgot already. So, ada tak? Okay, this one. So you can see you have XX 0, 1, and then here XX 1, 0. Referring to 0 part here, 0 to 1. 0 to 1, it will be 1x. And then at 1 here, 0 to 0. 0 to 0, it will be 0x. 0 to 0, 0x. And you fill in everything, we're going to get like this. So from here, you're going to come out with your care map. Care map K0, care map J0, care map K1. Why you need all this care map? Because you want to have the connections, how the connections look like. So only refer to your present state here. So you have, as I already informed you, it doesn't matter, you can draw like this also can. Aduh, semua. You can draw like this, Q0, Q1, Q2. It doesn't matter because you're going to get totally similar answer. We can also get the looks like this, Q0, Q1, Q2. Because everything's the input is similar and you're going to get similar output. So here it's already give you the example. Let's really look into J0 first. For the J0, you just fill in all the value inside here referring to your condition. If it is 0, 0, 0, 0, 0, 0, you have 1. If it is 0, 0, 1, you're going to have 0, 0, 1, x, and etc. This is fill in into your care map. You done already last time, several times. Still yet you follow your friend and you get the wrong answer. How come you can draw like this? I can't to understand. Okay, now let's after this, because you can see you got everything, then it will be 1. What else for JK here for this part? What is your input? You're going to refer to here. This one is Q0 and this is changing, then it will be Q0. For this side, I want it to fill in. Alamak, tapi dia bagi jawapan terus. It's okay. So how are you going to check chem maps? You're going to refer the value, right? If it's changed, you're going to ignore. Here also it's changed, going to ignore. This is fixed. It will be Q0. If the things that fix here is 0, 0, and then here may be 0 and 1, you're going to pick this as a Q1, but it is bar. This one is your chem map things. I hope that you still remember. Last time it's going to be like A, B, C, but it is totally similar. This is a variables also. And for this part, you can see refer to this. You can see this one is fixed. Your Q0, Q1, but your Q2 is changed 0 and 1. That's why you ignore that. Your answer is Q1, Q0. So how your connection, your JK flip-flop 1 is going to connect to your high. And then after that, your JK1, K1 is going to connect to your Q. And one last JK, JK2 is going to be Q0. And also, and, oh, sorry. I guess like that because this one is N, if you still remember, Q0 and Q1. So this is my input for my J, K2 and my J2 and K2. So let's take a look at the answer here. This is the part that I mentioned just now. And for your clock here, it is connected to the similar clock. This one is the timing diagram. If the question asks you, you need to know how to derive it, looking the output and also the input. Okay, let's do this thing. This is your clock. This is your Q0. Q0 is referring on your JK flip-flop, the normal one. So you're going to do toggle things. And this will be your positive clock. And second, and after that, you're going to get your Q1. How you're going to get your Q1 here? Your Q1 will be referring to your input of Q0. J, your value is now is K1 is referring to your Q0. So although you're going to trigger your inputs at this specific, your clock here is only this one. So referring to this clock, at this single line, what is the value of your Q? So you refer to your Q, right? JK. If 0, what is happened? So you're going to get your JK. J is 0, K is 0. So at this one, at this moment, you're going to have no change. So you go until your next clock here. Refer to your J and K value. J and K value is Q, right? Q0, right? So at this side, your Q is 1. 1, 1. That's why you're going to go toggle. And then continue until your next clock in this part. And for this part, your Q0 is 0. It's going to be no change. Until you meet another next one. At this part, your Q0 is 1. So you're going to go toggle. After that, you meet another, at here, you meet another clock. But here, your Q0 is 0. And that's why you have to do for no change. And then you do toggle here as Q0 as 1. And at this part, no change because Q0 is 0. And toggle. And do the similar things. Now you're going to refer to your Q1 and 0. At this clock, you're going to see where is the, okay, at this, now your Q0 will be Q1, Q0N, okay? So at this clock, what is happened to your value of your Q1 and Q0? So it is 0, 0. N, okay? 0, 0 will be 0, 0 will be 0. So it's going to be JK0. JK0, no change. Until you meet another clock at this side. Your Q0 is 1. your Q1 is 0. You're going to get 0 for your output side here. At this part, you're going to get 0. So it is no change again. 0 will be go to your J and K, okay, because it's connected together. And for this part, you have meet another clock there. For this, you're going to refer your value. Q is 0, Q is 1, so you have no change again. And this side is 1 and 1. So 1 and 1, what happened? Is going to be toggle. 1 and 1, you will get equal to 1. 1 will be fitting to J and K. So you're going to go toggle. You meet again 0, 0 here. 0 and 0, you will get 0. JK will be 0, no change. For this part also no change. For this part is no change until you meet 1 and 1. 1 and 1, you get N is 1. Value of JK is 1. It's going to be toggle. Let's try to do it one by one, referring to this flip-flop condition of your 3-bit synchronized counter. You're going to get the output of Q2 like this. Any question? Any question? I hope that you can try the design counter using T flip-flop. Do similar things, also similar to your D flip-flop, you can try to do. And do the 4-bit synchronized also. You just follow the example here, then you can come out with all the answer. Later, we're going to discuss in the Jamboard later on in our next class tomorrow. Any question? Tomorrow we will continue with our 2-bit counting down, synchronized counter. Basically, it's all similar, following the similar step. As long as you understand these 6 steps, you can come up with the answer. So any question?
No question, Doctor.
No question, Doctor.
Okay, if there is no question, we can stop our class now. We're going to continue tomorrow. Thank you for your participation. For those who still did not scan your QR code, please stay and scan first, and then you can leave. Okay. Thank you and bye-bye.
Thank you, Doctor.
You, Doctor.
Thank you, Doctor.
Okay, bye-bye.
Thank you, Doctor.
Okay.